Hi everyone, today we're going to study ordinary annuity. Let us recall, in simple interest and compound interest, an amount of money was deposited lump sum in an account and was left there for the entire time period. Now, we will do problems where timely payments are made in an account. Let us define annuity and sinking fund. When a sequence of payments of some fixed amount are made in an account at equal intervals of time, we call that an annuity. When the payments are made at the end of each period rather than at the beginning, we call it an ordinary annuity. If the payment is made at the beginning of each period rather than at the end, we call it an annuity due. The payment or deposit made each period in an account is called sinking fund. In this video, we will focus on the future value of an ordinary annuity. Remember, for ordinary annuity, that payments are made every end of the period. If a payment M is made in an account n times a year at an interest R, then the future value FV after t years is given by this formula. It looks like a real complicated formula, but just take note that this portion is like the total amount formula of compound interest. And then there is minus 1 here, and there is a denominator that is similar to this fraction R over N. Now let us see this example. Tanya deposits $300 at the end of each quarter in her savings account. If the account earns 5.75%, how much money will she have in 4 years? First, let us write the given of the problem, starting with the deposit M, and that is $300. Next is the number of times in a year that Tanya will do the deposit, and that is quarterly. That's why we write here N equals 4. The rate, denoted by R, is that 5.75%. And we will convert this into decimal, and this is equal to 0.0575. The time, denoted by T, equals 4 years. And then let us write our formula, and it is now written here. Let us do the substitution on this portion. So we have here the M now becomes 300. The constant one is here, plus the R over N is the 0.0575 over 4. And this same fraction we will write at the bottom. and the exponent here is the nt. So n, we have the 4, and the t is also 4. So we have here 4 times 4. And the constant minus 1 is now written here. Let us simplify further by getting the quotient of this fraction. So we will have 0.014375, and this same value we will write in the denominator here. Of course, the 4 times 4 is 16. Let us combine the constant one and this decimal. So we'll just simply put them together. So we'll have this 1.014375. Using our calculator, we can simplify this expression. So it means this decimal we will raise to 16. So we will have this 1.2565408. Then this will be subtracted by 1. So it means to say this whole number 1 here and the negative 1 here will cancel each other. Only the decimal will remain. So we have now 0.2565408. We will multiply this decimal with the 300. So the answer is 76.96224. And this will be divided by our denominator 0.014375. And the quotient will give us 5,353.89. This is our final value after 4 years. Of course, we will not forget the dollar sign. This is our final answer. Hi everyone. Today we're going to study sinking fund. Let us define sinking fund. Sinking fund is the periodic payment or deposit made in an annuity. This is the formula for the sinking fund. If the future value denoted by FV in an account after T years is deposited N times a year at an interest R, then the sinking fund M is denoted by this big formula here. M equals, there is a big fraction here. The numerator is the product of the FV times the fraction R over N. In our denominator, it is a little bit complex also. We have a binomial here, 1 plus the fraction R over N. And this binomial is raised into a power that is a product of NT. And then this whole quantity is minus 1. Take note that this formula is a manipulated version of the ordinary annuity. Let us see this example 1. Robert needs $5,000 in 3 years. How much should he deposit each month in an account that pays 8% in order to achieve his goal? Let us solve this first by writing the given of the problem. starting with the future value, that is FV, and that is the $5,000, followed by time denoted by T, and that is 3 years. Next is the rate denoted by R, that is the 8%. We will change this 8% into decimal. First, let us divide this 8 by 100. Of course, we drop the percent sign, and the quotient we will get 0.08. And the number of times in a year that Robert should deposit is 12. In here it's written each month. So 12 times in a year that Robert will do deposit. Our big formula is written here now. So let us do the substitution. So we can see here that M equals, in our numerator, FV is now 5,000, and multiplied to the fraction R over N, 0.08 over 12. So this fraction here is the same fraction that we will write in the denominator at this portion. So we have 1 plus that 0.08 over 12. And this binomial is raised into a power nt. N becomes 12 now, and t is 3. And then the minus 1 is a constant. Let us simplify further by getting the quotient of the fraction. 0.08 over 12 is now 0.006666. And this same decimal will appear at the bottom in the denominator. In our next step, in our numerator, we will multiply the 5,000 by this decimal. So we will get 33.33. In our denominator, we will add this constant one plus this pure decimal. Simply, we will combine them together. So we have 1.006666 that is raised to 36. And that minus 1, we will simply copy. We can get the simplified value of this decimal raised to 36, and the answer is 1.270207. And if we subtract this by 1, this whole number 1 here will disappear, and only a pure decimal will come at the bottom in the denominator. So we have now 33.33 divided by 0.270207, and the answer is 123.35. This is our M. This is the sinking fund. Of course, we will attach our dollar sign, and this is our final answer. Let us see example 2. A company has a $120,000 note due in 4 years. How much should be deposited at the end of each quarter in a sinking fund to pay off the note in 4 years if the interest rate is 8%? Let us now write the given of the problem, starting with our future value. That is the $120,000. Next is the time denoted by T, that is 4 years, followed by the number of times in a year that the company must deposit the amount, and it's written here each quarter. For our n, it will be 4. There are 4 quarters in a year. Next is the rate, denoted by R. That is the 8%. We will convert this 8% into decimal. We will write first this 8 over 100. We drop that percent sign, and then we will get the quotient 8 over 100. That is equal to 0.08. Our big formula is now here. So let us now start doing the substitution. Our M equals the FV, or the future value, is now 120,000 times the fraction R over N. So this is now 0.08, that is the R, over 4, that is the N. The same fraction will come down here. We will copy the constant 1, and the exponent will be NT. And NT is 4 times 4. And we will copy the minus 1 in here. Let us simplify further, first by getting the quotient of our fraction. 0.08 over 4, that will be 0.02. The same decimal will come down here. For our next step, we will multiply this decimal with a 120,000, so we will get 2,400. In here, we will combine this number 1 plus the pure decimal, so we will get 1.02. We're going to raise this value into 16, and the value is 1.372786. And then we will subtract this by 1. It means this whole number 1 here will simply be eliminated. Only the pure decimal will come down, and that is the 0.372786. And then we will divide 2,400 divided by 0.372786. And the quotient is 6,438.01. We will attach the dollar sign. This is our sinking fund. This is our final answer. Hi everyone. Today we're going to study Annuity Due. Let us define Annuity Due. When a sequence of payments of some fixed amount are made in an account at equal intervals of time, we call that an annuity. If the payment is made at the beginning of each period rather than at the end, we call it an annuity due. Let us define the future value of annuity due. In the case of an annuity due, to find the future value, we apply similar pattern of formula of ordinary annuity, but increase the number of periods n by 1 and subtract 1 payment. This is our formula. This is similar formula of ordinary annuity. The only difference is in this portion that we are adding 1. Also, there is a minus m in here. So this is our big formula for annuity due. Let us see this example. If at the beginning of each month a deposit of $500 is made in an account that pays 8% compounded monthly, what will the future value be after 5 years? Let us write the given of the problem, starting with the sinking fund or the monthly deposit, and that is the $500. Next is the rate denoted by R, that is the 8%. Let us convert this 8% into decimal. First, let us drop the percent sign and divide this 8 by 100. And then the quotient will give us 0.08. The next given is the number of times deposit is made in a year. It says here each month. So we write n equals 12. The time denoted by t is 5 years. Then we write the big formula here. Let us start now the substitution. In our formula, the m is found in two places, which is here, where the m is changed now into 500, and also in here. And then the constant one we copied, plus the fraction r over n. So we have 0.08 over 12. The same fraction is found in the denominator here. And in the exponent, we have nt plus 1. That is the 12 times 5 plus 1. So on the next line, we will simplify this formula further, starting with the fraction. The 0.08 over 12 is now 0.00667. And this same decimal is used in our denominator. And the 12 times 5 is 60, plus 1 becomes 61. So our power now, or exponent, is 61. And then, inside this grouping symbol is the constant one plus the pure decimal. We'll just combine them together. So we have 1.00667, and this value now is raised into 61. Using our calculator, the value will be 1.499808. And then we will subtract this decimal by the constant 1. So the whole number here of the decimal will simply be deleted, and only the pure decimal will come down. So we have now 0.499808. In our book, we can see that this decimal here is divided into the decimal down here. So we can follow that pattern. And the quotient will be 74.967452. So we copy that 500 down here, and the minus 500 is still here. So let us multiply this 500 and this big decimal here, and we will get the answer 37,483.73. We will subtract 500 from this value, and the answer will be 36,983.73. there is a slight difference with the decimals from our textbook because of the rounding off. So this is now our final value, and of course we will write our dollar sign. This is our final answer. I hope you learned something from this video. See you again next time. Hi, math enthusiast. I would like to invite you to join us and be a member of e-DEOlogy community. If you become a member, you will help e-DEOlogy YouTube channel to make more math videos and to ease logistics expenses. As a member, here are your perks. All members will receive this beautiful and customized e-DEOlogy Fun Badge. There are 3 levels of membership. The first level is Bronze. Bronze members enjoy 100% of videos, plus Bronze Certified Member Badge that look exactly like this. The second level is Silver. Silver members enjoy 100% of videos, plus you will receive the Silver Certified Member Badge, and it is here. As a Silver member, you are considered to be a sponsor of 3 members-only videos, plus you are a sponsor of 1 public video. This public video means these are merged videos of 3 to 7 math topics. As a sponsor, acknowledgement is given on the latter part of the video, that is, your name or your channel is shown as one of the sponsors. The third level and the highest is Gold. Gold members enjoy 100% of videos, plus you will receive this Gold Certified Member Badge, and it is here. As a Gold member, you are considered to be a major sponsor of 30 members-only videos, plus major sponsor of 10 public videos. As a major sponsor, acknowledgement is given on the early part of the video, that is, your name or your channel is shown as one of major sponsors. See you all in e-DEOlogy community and get this beautiful e-DEOlogy Fun Badge and be a member according to your interest as a Bronze member, a Silver member, or a Gold member. We love to see you in e-DEOlogy community.